Hello everyone and welcome. I would like to highlight that this lab has been inspired by a great blog written by 𝐂𝐨𝐝𝐲. I highly recommend to you to read this blog for further read. According to 𝐂𝐨𝐲, loop engineering is replacing yourself as a person who prompts the agent. You design a system that does it instead. Specifically, what it means is that in the traditional approach or a current approach that we are interacting with AI agent is that we provide a human written prompt to the AI agents, and we as a user, we will review the output. And if you're not happy with the output, we would rewrite the prompt and we repeat this process until the goal has been achieved. So the challenge with this approach, as you can see, is quite manual, it's repetitive, it's inconsistent, and obviously as it is manual and repetitive, it is hard to escape. Loop engineering instead, it tries to solve this problem. We as a user, we design and define the systems based on the task and criteria that we have in our minds. And we give it as an input to a prompt generator, which can be an AI agent that is responsible to generate a prompt given the input that we provided. And then the output of the prompt generator would be fed to our main LLM model that we have to conduct the reasoning, and we have output out of that. And we have another AI agent, which is responsible to check and evaluate against the criteria and the task that we have designed. And the refinement is happening. This process is happening in loop, therefore we call it loop engineering. And obviously, we need to keep a track of changes. And we need to define a kind of memory here. And after repeating this loop for several times, we will come up with our best models. And that would be we would go out of this loop and we use this specific prompt for our main task. So you can see that the paradigm is moving from you prompt the agent toward you design a loop. So in this lab, we would like to go beyond the simple command like a /goal or a /loop. We would like to go to the detail, what is happening under the hood. So for this task, we are going to use this workflow. We start with a small language model. In this case, I'm going to use Qwen 3.59 billion parameters. Then we create chat functions. We define the skills for our AI agents, both for our prompt builder and also agent, which is responsible for checking the quality of the prompt. And then we create a loop here, and we obviously keep a track of changes which is happening along the way. And finally, we select the best models and compare the results. Specifically, we have two methods to test and compare in this lab. One of them is baseline, is a single pass generations, or like basically with the prompt engineering, we write one-time prompt to the models. We define the task for that, and we get the output. And the other approach is an iterative loop, which is in a combination between a maker agent and checker agent, which are interacting with our language models. So, as I mentioned, we are going to use a small language model which is hosted in my local machine. I have provided a full tutorial on Lab 5 of the Apply the Small Models AI Lab. Unfortunately, from the date that I'm recording this video, this lab has not been released. You need to be a little bit patient, but for a time being, please rely on the information that I provided here. So I am personally using Llama server for this lab, and I'm using OnSlot's framework with the local GGUF models. We are going to use the OpenAI SDK for communicating with my local host. Obviously, in this tutorial, I'm using SSH port forwarding as I have my local machine sitting remotely. And And option B is that if you do not have access to your to a strong machine, you would be able to use based on the API OpenAI API key by simply claiming your OpenAI key here, and you would be able to do that. I provide the code snippet there, so you would be able to do it in a very easy way. So as I mentioned, the first step that we need to do is to install the OpenAI SDK to communicating with our local machines. And as I mentioned, this code is served to just check that everything is up and running. And you can see that well, server is running, so it means that we have access to our local machine, which is Qwen 3.5. And as you can see here, I would just ask, hi, how are you? And I'm running that on Llama CPP, and it said, well, who are you? Say that, well, Qwen 3.5. So now here in Notebook, we need to communicate with that, and we need to ask you questions. This one, as we are going to use that, we need to simply run this part of the code. As I mentioned, all this detail about this code snippet has been provided in Lab 5. We are using OpenAI SDK as a base URL. We are providing our local host where we host our models. And API key, as it is running on my local server, we do not need that. If you would like to run it based on OpenAI API key, then you can use this code snippet, and you could forget about this part and the previous part of the code. So the next step, what we need to do, we need to create a chat function, which we would be able to chat with the models. Again, for this part of the this building block of this lab, you're more than welcome to review Lab 1 and Lab 2 of Applied Small Models AI Lab, where I discuss in detail about the element of language models as well as chat templates. And everything has been discussed there. However, for this lab, as I mentioned, we are going to use the OpenAI SDKs. We need to set the temperature here to 0.7. The higher temperature you have, the more creativity model would have. And this code snippet, it just want to check that everything is up and running before we dive into our actual examples. So you can see that through the OpenAI SDK, we are able to call the chat completions. We give as the input our local models, and in the case that you are using OpenAI SDK can be it can be exactly the same, and basically we would be able to give as the input the message, and then we will have a temperature here which sets the creativity of the model. The lower, the less creative model could be, and then we will have the context window that the model is able to digest at a single runs. As the input, as I mentioned, we need to give the input message that we defined here. As you can see, as the input, we give it to the model a chat template, which the role would be the user. It means you. The content that you give it to the model would be say hello in one sentence. And if everything up and running, we need to see a result instead of, well, say hello in one sentence. The result is that hello. So it means that it's communicating effectively with our Qwen 3.5. So there is no problem here. Now we are going to create a baseline. So what we would like to do here, we would like to define a task. Our task would be to the Qwen model, write a concise explanations of a gradient descent for a complete beginner. Use an analogy. So and then the and what we would like to do as an input, we would define the role for a model, which is the system, and the content of that would be, you are a helpful teacher, be clear and consistent. So we would expect that the Qwen model act as a kind of helpful teacher, and the user would be you would ask, it can be you that you would ask, explain me in a simple language what is gradient descent, and you could see that you will get kind of output here, and you would be able to see some information. And if you want to now refine that, if you're not happy with it, you need to do a prompt engineering. So you change a little bit prompt, and you try to refine it a little bit, and then you rerun it. So this process is manual, so you need to repeat it several times. Now we are moving toward loop engineering right now. For loop engineering, what we need to do, we need to define a skill for models that we would like that model would follow. So rather than prompting every time, we write it, we codify that one time, and we reuse it for many times. So what we are doing is that the writing skill that we would like that the model would follow would be, you are an expert technical writer. Your quality criteria for any explanation would be analogy, brevity, jargon-free, and actionable. And we ask that to the AI model to rate each criteria as pass or fail, and be strict about that. For refinement skills, is that we are asking that you are a rewriter, and given the feedback on a piece of writing, improve it, and keep the core idea, and like basically come up with a fail point in the feedback. And do not add unnecessary lengths. Obviously, we would be able to change these skills, but here is the example. So we codify it, we give it later on, we define the skill for models to follow these strict rules. And after that, what we are going to do is that we build the maker agents and we build the checker agents, that the agent is responsible to generate the prompt, and the agent is responsible to check and evaluate the prompt that we have been able to generate. So basically, maker is draft or refine the output, and checker is able to evaluate the skills against the criteria that we have defined. So here I create already these two sub-agents, and you can see that the sub-agents have been created. And according to loop engineering, now the interesting part is that we need to loop around and find the best results. So you can see that we are going to look at the running loop, log, or to keep a track on the memories and output, and then we select the output. So what we're going to do here, the most important part is to keep a track of what is happening in the model. So it's important, so for this lab, we create a JSON file. So in each loop, we would be able to write the output to the model according to the performance that we get from the models. So it keep a track that how maker and checker are interacting with our main language models. So we have like for these in this JSON file, we have information on the iterations, timestamps, output, feedback, and a score. And finally, we are also saving the best results. So the output, it look like this one. So you have iterations, the first iteration, the timestamp, the output, it will be saved here, the feedback that we get, and the score. It means that out of 4 criteria that we have defined, how many of them have been adhered, and finally, we get the best output. So, and this path, it means that if this let's say loop has been passed or failed, and here it has been identified as a fail because 2 out of 4 criteria has been adhered. And after that, what we need to do, we need to create a loop and let that model run. So let's see the output. Let me see. All right, we need to run that. Name error task. Oh, I forget to run that part. Yes, let's rerun that. and we go now here. All right. So you can see that we have 4 criteria out of 4 need to be achieved in order to be to pass, and you can see that our model is able to, after the first iteration, 3 out of 4 have been achieved. So it means that the first prompt that we have been created, the analogy has been achieved, the brevity has been achieved, and jargon-free has been achieved, but it didn't come with a kind of actionable suggestion. So it has been failed here. While for the other prompt in iteration 2, 4 out of 4 criteria have been achieved. So it means that we do not need to really go and then handcraft the prompt by ourselves, but the model itself is able to come up with that. So now let's see what is the comparison between the baseline, which is a single pass, and comparison with the other method here, which is based on loop engineering. And you can see that it is much more concise once we are looking at that. So it come up with a sentence here, it come up with bullet points, and try to explain it, but maybe it's a little bit long. But anyway, I give the output to the LLM before this lab, and I ask it to basically compare them. And you can see that here is a comparison: baseline, which is a single pass, and loop, which is the best output. So the insight that we are able to get in terms of clarity, the loop output is easier to read quickly. Both of them are used analogy well, but the baseline is more vivid. In terms of brevity, the loop output is better and satisfy the brevity criteria. Jargon-free, the baseline explains jargon better. The loop is simpler in overall because we want it to be jargon-free. And in terms of actionable embedding, is that the loop output is more actionable. Educational depth, it said that baseline is better for teaching, and the loop output is better for quick understanding. Yeah, so the overall quality is that the loop improves the answer by optimizing toward the explicit quality goal. So in general, we have been able to somehow automate the manual process of prompt engineering. And the other thing that I would like to show you, you can see that, we have 4 out of 4 criteria, and after 2 runs, we have been able to achieve our goals. And then after that, I would like to also show you that, how we have been able to keep a track of the memory. And as we can see that we save the memory, we save the output in a JSON file, save in our local machine, and we can see that we are able to retrieve that as well. So, and after that, we can kill the sessions. But the point that I would like to also highlight here is that many people these days, they use /goal and /loop blindly, and I think this is very dangerous activity that the user are doing, running the things and wishing for best. I strongly believe that this is not the right approach, and we really, to some extent, we really need to understand what's going on under the hood. That would help us to think better. That will help us to design our model in a better way, and that make a clear difference. So in this lab, what we have learned is that with a simple example, we learn about automations. We create a Python for loop as a trigger to automate across 2 different agents. We define 2 different agents, maker and checker. One important thing that I forget to mention, that for maker check agent, we need to keep the temperature higher for creativity. But once it comes to the checker agent, as we would like to do evaluation, we do not have much room for creativity. So we need to be strict. So the checker agents, the temperature level need to be to the lower value. We learn about how to keep a track of of the memory with a simple JSON file. And obviously, this is not scalable. You could use SQLite database, or other database exists for scalability. And we learn how to define a kind of goal to reach our specific criteria that we have been defined. There are much to do. There are a lot to do. But the first step I highly recommend is that to read about the blog by Adi Osmani, as well as I will also write a blog on that. I would highly appreciate if you also review that and provide your comment there. As an exercise, if you're interested, you could move on and replace a JSON file for SQLite dataset for multi-loop tracking. You could also add the sub-agents that use the output of the models of the generated prompt, and also refine that and keep a track of them to be able to give a hand to the AI algorithm to be able to come up with a better prompt to fit to the models. You could be focused on a real task, working with the GitHub repository, and working on a bigger database, but you really need to be careful what you're defining, and you could also try with the different language models like Qwen 3.6, Gemma 4, 12 billion, and all the others. So the thing that, again, I would like to highlight, that do not use these type of skills blindly, because you could end up to really burn a lot of tokens without getting any kind of results. So by this, I wish you all the best, and I'm looking forward to produce another video to discuss about another cool topic with you. Thank you very much.